question number 5, look at here. You are given the electrode potential for lead, and then this is the value of the electrode potential, while copper is positive 0.34. Now for the galvanic cell standard condition, we need to calculate the cell potential for the reaction if the concentration of lead 2 plus and copper 2 plus is 1.0 and 0.1 molar. So first of all, we need to sketch the cell. Here we have the lead solid and the copper solid. So both of the electrode are connected with the wire via the voltmeter, and then each of the electrode must be immersed in their ion solution. Okay, so we must show that the lead is immersed in the Pb2 plus ion, while copper immersed in copper 2 plus solution. Next is to label the voltmeter, and then the electron flow from anode to cathode, and then anode, label anode which undergo oxidation while cathode undergo reduction. The sign for the anode is negative because Pb is the source of electron, while copper 2 plus is positive because it need electron or it attract electron. To determine who is anode and who is cathode, we refer to the standard electrode potential given. Okay, the more negative the compound, the electrode potential, so the more electronegative, the more negative is the higher tendency to donate electron. Or you can otherwise you can memorize like this: the more positive the electrode potential, the higher ability to pull the electron. So to pull the electron, it must be positively charged, which is it cathode. Okay, so kaedah yang kedua adalah kalau you nak ingat sebelah lagi, iaitu lebih negatif sesuatu compound, sesuatu electrode, lebih mudah untuk dia menghasilkan elektron. So bila hasilkan elektron, keluarkan elektron, undergo oxidation di anode. Okay, so it's up to you whether you want to memorize the more negative to be anode or the more positive to be cathode. Okay, hanya ingat perlu ingat sebelah je lah, anode ataupun cathode, tak perlu ingat dua-dua. Okay, next, don't forget to connect both of beaker with the salt bridge and label the salt bridge. Okay, next is to write the cell notation at the anode. Anode undergo oxidation, where Pb solid donate electron. So if donate electron, it is loss of electron, then the electron at the right side. Donating electron to form Pb2 plus aqueous. So the aqueous ion, okay, Pb solid change to Pb aqueous, so the Pb ion will enter the solution. So Pb2 plus concentration will increase. Next, at the cathode, when the Pb solid donate electron, the electron is coming up from the anode and then going through the wire and then come to the cathode and reduced by the copper 2 plus. So copper 2 plus will receive the 2 electron that come. Copper 2 plus aqueous from the solution receive 2 electron, become copper solid. So the copper solid will deposited here. Okay, and then overall equation, how to construct overall equation? We just combine the left side of anode equation with the left side cathode equation. Okay, kanan dengan kanan. Tapi sebelum kita combine kiri dengan kiri, kanan dan kanan, kita kena tengok both electron must be cancelled equally. So 2 electron at the right side cancelled by 2 electron at the left side. So we just combine. Left side we have Pb and copper 2 plus. Right side we have Pb2 plus and copper solid. After that, we construct the cell notation. We are referring to the ABC rule. A is referring to the anode, B is the bridge, and C is referring to the cathode, where Pb solid become Pb2 plus. Whenever it involve aqueous solution, kita mesti tulis dia punya phase dan juga molarity. While at cathode, copper 2 plus receive electron to be copper solid, and copper 2 plus is aqueous phase and 0.1 molar concentration. Okay, so solid, aqueous, aqueous, solid. Jangan lupa, kalau dia aqueous, give the concentration. Kalau dia gas, give the pressure of the gas. Next, calculate the cell potential for the reaction if the concentration of Pb2 plus and copper 2 plus is 1 molar and 0.1 molar respectively. So sekarang kenapa dia kata E cell potential? It is because the concentration of solution here is not 1 molar. It is not standard. Therefore, we need to use cell potential from the Nernst equation. Okay, before we calculate this cell potential from the Nernst, we need to calculate the standard cell potential where we use cathode minus anode. Okay, the electrode potential cathode minus anode is copper, cathode minus anode is lead, and the standard cell potential is positive 0.47. Finally, substitute into the Nernst equation. Nernst equation is the E cell 0.47 and 0.0592 over N. N is the number of the electron cancel. Here we are cancelling 2 mole of electron, so divide by 2, and then log product over reactant. Please refer to our overall equation. The product is Pb2 plus over reactant. Okay, so solid dia tak masuk dalam equation. So here we have Pb2 plus over copper 2 plus. Okay, and substitute the concentration, and finally the cell potential is 0.44. So this is the cell potential if it is in standard condition, but due to the concentration is 0.1 molar, therefore the cell potential is less than the standard. Next, question number 6. Galvanic cell constructed by the reacting with nickel plate, okay, was immersed in 1.5 nickel solution, and the other electrode is aluminium plate, was immersed in the solution, consists of X molar Al3+. The cell voltage is 1.0 volt. Okay, so let's check whether this reaction which the cell is conducted in standard condition or not. So if we are looking to the concentration given, it is not at standard condition. Okay, not standard. So if not standard, you are going to use Nernst equation. Okay, but first of all, question asked to calculate the standard cell potential. So standard cell potential is E naught cell. This is for standard, where cathode minus anode. So here, given the standard cell potential for aluminium and nickel, okay, the more negative will be anode. Here anode is aluminium, so nickel will be cathode. This is cathode and this is anode. Okay, so sekarang kalau kita apply nak cari E naught cell, standard cell potential is cathode 0.25 minus anode negative 1.66. So this is the voltmeter reading if we construct this cell in the standard condition. Okay, since the concentration is not 1 molar, therefore we can calculate the cell potential. Okay, determine the value of X. The value of X is referring to the concentration of aluminium 3+. Before we apply, okay, we can find the concentration from the Nernst equation. Okay, but before we substitute into the Nernst equation, we must make sure that what is our overall equation. Okay, so sila pastikan pelajar menulis overall equation sebelum menggantikan ke dalam Nernst equation. Okay, sebelum kita nak buat overall equation, kita mesti buat reaction di anode, aluminium undergo oxidation, and form Al3+, while the other one is in the nickel will be cathode. Nickel 2+ will receive the 2 electron and become nickel solid. So because of the electron cancel is not the same, so we need to multiply the equation so that we can cancel the same number of electron. The equation at anode we multiply by 2, while cathode we multiply by 3. Okay, so we are cancelling 6 electron right side, 6 electron left side. Therefore, combine for the overall, left side we have 2 aluminium and then 3 nickel 2+. Right side we have 2 Al3+ and 3 nickel solid. Okay, that means this is the correct overall equation. After that, we substitute into our next equation. The E0 cell given from the voltmeter. Okay, that means that is the voltmeter reading at non-standard. Ini kita boleh dapat daripada bacaan voltmeter yang kita pasang pada sel tu lah. Okay, so we have the cell potential, and the standard cell potential is what we have calculated before, and then 0.05, and the electron cancel. See, we are cancelling 6 electron left and right side. Log product over reactant. The product is Al3+. Okay, Al3+, divide by concentration and nickel 2+, Al3+ over N2+, and the Al3+ is has coefficient 2, so it is power of 2, while nickel 2+ power of 3. Okay, so that is the important part where students need to construct the overall equation correctly. If we just estimate or we just predict, okay, without doing this overall equation, we might forget to put this order, power respect to their concentration, product over reactant. Okay, so pastikan nak dapat benda ni yang betul, kita kena buat overall equation yang betul. Overall equation kena buat half equation. Okay, and then kita just substitute the value of concentration X aluminium 3+ tu, tak tahu dia bagi X, just substitute, and then finally the concentration of X, so ini adalah X square root answer kita akan dapat value X, which refer to the concentration of Al3+, which is 5.901 molar. Okay, question number 7. Galvanic cell consists of lead anode immersed in 1 molar solution, and then platinum cathode has gaseous hydrogen bubbling at a pressure 180 m, and the ion concentration of H+ is 1.3. So the concentration of H+ is non-standard. Okay, so this cell is between lead and hydrogen gas. Okay, and the platinum is used to receive the electron only. Okay, in this case, write the cell notation. Before we write the cell notation, we need to determine who are going to be anode. More negative to be anode. So lead will be anode and hydrogen will be cathode. Okay, so let's write the half equation where lead undergo oxidation, okay, release electron to be lead 2+, and hydrogen plus in the solution receive the electron to form hydrogen gas. Okay, by right we can cancel 2 electron both side, which is equal number of electron, so we just combine left side and the right side. Finally, we will produce our overall equation. From the overall equation, we need to write the cell notation. Okay, so cell notation is anode, bridge, and cathode. The bridge, the anode is Pb solid to Pb2+. Pb2+ adalah aqueous 1 molar concentration given, where at the cathode is the H+ aqueous concentration given, receive electron to be hydrogen gas at 1 atm pressure. And at the cathode, we are using the platinum electrode. So kita letakkan platinum electrode di paling hujung paling kanan lah. Kalau katakan hydrogen electrode tu ditakdirkan menjadi anode, okay, platinum electrode ni kita tulis di sebelah yang paling kiri. Okay, so kalau dekat sebelah anode, platinum paling kiri. Kalau di sebelah cathode, hydrogen, kita kena letakkan platinum di sebelah paling kanan. Okay, soalan seterusnya adalah calculate the cell potential of E cell. Okay, so disebabkan concentration dia tadi bukan pada 1.0 molar, dia adalah non-standard condition. So bila non-standard, kita terpaksa menggunakan cell potential, iaitu menggunakan Nernst equation. So belum guna Nernst, kita pastikan kita menggunakan kita ada overall equation yang betul. Before that, we have calculate our standard cell potential, cathode minus anode, positive 0.13, and then substitute into our cell notation. Nernst equation. This is the standard cell potential, 0.0592 divided by 2, because 2 electron cancel. Log concentration product over reactant. Okay, from our overall equation, our product consists of lead 2 plus equation solution and hydrogen gas. So we put the concentration of the ion and the pressure of gas. Divide by solid is not included in the equation, so we divide by the concentration of H plus power of 2, the stoichiometric coefficient. Substitute the value, and finally the cell potential of this cell will be negative 0.1959 volt. So inilah bacaan bila kita set up sel yang kita maksudkan di sini pada bukan standard condition. Okay, so bacaan voltmeter adalah ini. And then predict the spontaneity of the reaction. So since bacaan cell potential kita adalah negative, the cell potential is less than 0, so it is non-spontaneous. So dia tak boleh generate electricity. And these are the objective question. That's all. Thank you for listening.